Hello student, welcome to all of you in the next physics lecture. Now we have to start here the new chapter, that is the gravitation. This is a very important chapter. We have to learn here in 12th standard the three types of the motion. First is the circular motion, second one is the gravitational motion, and third one is the rotational motion. So that this gravitational motion is also very important. And we have to start here this gravitation with the Newton's law of gravitation. First, we have to say here the introduction about this Newton's law of gravitation. This is very important. The statement is like that every particle of matter is attract with the every other particle of matter with a force of attraction which is directly proportional to product of their masses and inversely proportional to square of distance between them. The statement is like that every particle of matter, also we can explain in this diagram. We have to take here the consider two particles of masses m1 and m2 here, m1 and m2. These are the two particles of masses m1 and m2 separated by the distance, that is the small r, which can be separated by the distance small r. Then thus according to this law, the force of attraction is like that, Ff is the force of attraction which is directly proportional to product of their masses. This force of attraction which can be directly proportional to product of their masses, that is the m1 and m2, and inversely proportional to square of distance between them, that is the r, that means r square. F is inversely proportional to r square and F is directly proportional to product of their masses, that is the m1 and m2. Okay, understand? Every particle of matter attracts with the every other particle of matter with the force of attraction and which is directly proportional to product of their masses and inversely proportional to square of distance between them. This is the statement for the Newton's laws of gravitation. You have to learn about this, the Newton's law of gravitation statement, then the gravitational constant, that is the capital G, and also you know that the unit and dimension of that gravitational constant G. For that purpose, this is the diagram. Where to take the two particles of masses m1 and m2, the separated by the distance r, and F is the force of attraction between them. Then according to the law, then we can write here according to this law. This law is state that the particles of this every particle of matter attracts with the every other particle of matter with a force and which is directly proportional to product of their masses. We have to take here the product of masses, that means the m1 and m2 are the two particles of masses. Therefore, F is directly proportional to product of their masses m1 and m2. Suppose this is the equation number 1. Then again we have to also say here that this force of attraction which is inversely proportional to square of distance between them, and so that F is inversely proportional to r square. This is the equation number 2. If you have to combine these two equations, F is directly proportional to m1 m2 and inversely proportional to r square. If I have to combine, then F is directly proportional to m1 m2 upon r square, directly proportional to product of their masses m1 m2, inversely proportional to square of distance, that is the r square. Therefore, F is proportional to m1 m2 upon r square. Now we have to remove here the proportionality sign. Then what is this? F is inversely proportional, directly proportional to m1 m2 upon r square. Then F is equal to G, that is the constant, and which is called as a gravitational constant, that is the capital G. F is equal to G into m1 m2 upon r square, where G is a constant and which is called as a gravitational constant. Then we have to find out the value of this gravitational constant G. G as it is, this r square is take this side, therefore G is equal to F into r square upon m1 m2. This is the gravitational force. G is equal to F into R square upon M1 M2. Then from this formula we can find out the SI and the CGS unit of the G, and also the dimension of the. Now from this formula, G is equal to F into R square upon M1 M2. From this we can find out the dimension as well as the SI and the CGS unit. Then the SI unit of G is what? From this formula, F, that is the force which can be measured in Newton. Then this is the distance which can be the R square. Therefore we have to take here the meter square. Newton meter square upon, that means per, and mass is M1 M2 is double, therefore M square meter square. Therefore SI unit of G is Newton meter square per kg square. Mass is measured in kg and this is double one, therefore kg square. Newton meter square per kg square. Similarly, the CGS unit of G is nothing but what? Dyne centimeter square and per gram square. Dyne centimeter per gram square. SI unit of G is Newton meter square per kg square, and CGS unit is dyne centimeter square per gram square. This is very important. Also the unit of the G. Also we have to find out the dimension of the G from this same formula. G is equal to FR square upon M1 M2. Therefore we have to substitute here the dimension about this F. G is equal to FR square, F into R square upon M1 M2. Then we can substitute the value of this dimension of force. G is equal to F. The value of this dimension F is what? L1 M1 T minus 2. R square simply L2, and M and T are the 0. Again mass is M1 M2. Therefore we can write here M2, that is the M square. Okay. Then this base same multiplication, then we can add the power of this same quantity. Therefore 1 plus 0, 1. Then L raised to 1, L raised to 2, 1 plus 2, 3. And minus 2 plus 0, minus 2. And M2 as it is. Then M1 and this plus 2, take upward side, minus 2. 1 minus 2, minus 1. Therefore M raised to minus 1. L raised to 3 as it is. T raised to minus 2 as it is. And this is the dimension of the G. L3, M minus 1 and T minus 2. This is the dimension of the G, that is the gravitational constant. This Newton's law of gravitation, which is hold for all the material objects. Therefore it is called as the universal constant, or this constant G is also called as a universal constant, and having the value, the G having the value that is equal to 6.673 into 10 raised to minus 11. 6.673 into 10 raised to minus 11 Newton meter square per kg square. This is nothing but this gravitational constant value of the G. 6.673 into 10 raised to minus 11 Newton meter square per kg square. This is the Newton's law of gravitation. This is the very important. And from this relation we know that the small g, that is the acceleration due to the gravity. Then also we have to relation between the capital G and the small g, which is very important in your this chapter. This relation is not given, it is given by the directly, but we have to learn here what is the relation between the capital G and the small g. This is a very simple one. We have to take here in this. Now the relation between the G and G. We know that the capital G is the gravitational constant and small g is the acceleration due to the gravity. Both value you know that. Capital G 6.673 into 10 raised to minus 11 Newton meter square per kg square, and G is nothing but you know that well, this 9.8 meter per second square. Okay, then what is the relation between them? This is the very important. Suppose we have to consider here the capital and capital R be the mass and radius of the earth, and small m be the mass of an object. Mass of an object. Any object. We have to take here the satellite. This is the object. Then m is the mass of an object on the earth surface. This is very important. If you have to take the object is at the height h above the earth surface, then the radius of orbit we have to take here the small r is equal to capital R plus h. If the object is at on the earth surface, then we have to take here there is no height, Therefore, small r is equal to capital R. You have to learn and remember this point. Okay. And if g is the acceleration due to the gravity at the earth surface, then there should be one condition, and that is the weight of an object which is always equal to the gravitational force acting on it. Any body which is on the earth's surface at that time, the weight of an object or the weight of that body which is always equivalent to the gravitational force acting on it. And so that we have to take here this weight of an object which is equivalent to the gravitational force. We know that weight of any object, weight of any body which is equivalent to what? mg. And the gravitational force which is also, we have to find out here the gmm upon r square. We have to first of all here the m1 m2, but capital M is the mass of the earth and small m is the mass of an object. Therefore, we have to take here m1 and m2. Instead of m1 m2, we have to take here the capital M and the small m. Therefore, weight of an object mg is equal to gravitational force gmm, capital M into small m, upon r square. We have to take here the capital R because this object is at the earth surface and there should be no height. Therefore, we have to take only the capital R square. If there should be the object is at the height h, then instead of this small r, we have to take here capital R plus h. Okay. Therefore, mm should be cancelled and g is equal to gm upon r square. Therefore, g is equal to gm upon r square. This is the relation between the small g and the capital G, relation between g and g. Then we have to find out also this gm is equal to gr square. In the next derivation for the escape velocity, critical velocity, we can substitute the value of this gm is equal to gr square. Then if suppose that this object is at the height h above the earth's surface, then what will happen? If the object is at the height h above the earth's surface, at the height h above the earth's surface, and gh is the acceleration due to the gravity at this height. Gh is the acceleration due to the gravity at this height. Then we have to take simply this weight of object. Instead of mg, we have to take mgh, and the gravitational force gmm upon r square. Instead of this r square, we have to take here at height h, so that we have to take here the r plus h bracket square. Then again small m is cancel and gh is equal to gm upon only r plus h bracket square. Instead of r square at the earth surface, we have to take at the height h above the earth surface r plus h bracket square. This is the relation between the g and g at the height h above the earth surface. Again the value of gm we have to find out here. Instead of gr square at the earth surface, at the height h, gh into bracket r plus h bracket square. This is the relation between G and G. Understand you? Okay, stop here.